Hello everyone and welcome to our Introduction to TypeScript course. I'm Giuseppe Maggiore and together with Dr. Francesco Di Giacomo it will be my pleasure to guide you through this series of lectures that will take you from absolutely no initial knowledge to being an intermediate TypeScript developer. Today's first class is going to give a short tour of where we are going to go with the course. I will show a preview of the materials. I will introduce the reasoning behind the course. Why would you want to learn TypeScript? A little bit of the history of TypeScript, and perhaps most importantly, our first hands-on live coding experience, where we're going to see how to set up a TypeScript project from the ground up. First of all, let me start with a bit of motivation. Why would we want to learn TypeScript? The reason is quite simple. TypeScript is a hugely popular language, makes it useful as a tool in your professional arsenal because there are plenty of companies that are hiring TypeScript developers for all sorts of applications. Mostly TypeScript can be used as a front-end programming language, but in some cases it can also be used as a back-end programming language when coupled with Node.js. TypeScript is an excellent complement to hugely popular front-end frameworks such as React, such as Angular, such as Vue.js. TypeScript also has something else that's quite interesting. It's a very well beloved programming language. It ranks very high in the most appreciated programming languages in the software developer community all over the world. This means that TypeScript is not only useful in practice because plenty of companies use it, but developers are actively pushing in order to be able to use it more. TypeScript is also open source, meaning that it's not intellectual property of any company that might all of a sudden pull the plug on the project, make it paid, add licenses or whatever, so that is good. But at the same time, Microsoft stands firmly behind it and pours a lot of money, effort, and know-how into making sure that the language keeps moving, keeps evolving, while staying retro-compatible. So if you sum it up, it's useful, it's very used in the industry, it's good for backend, and mostly it's very good for frontend. It's very much appreciated. It is open source. It has corporate backing. What's not to love, indeed. How did TypeScript come to be, though? That's also interesting, because in the old days, as you might know, there was JavaScript in the browser, and JavaScript was originally the only way to add some degree of intelligence to web applications without having to involve the backend and the server for every little operation. This made it possible to, for example, build the first Web 2.0 applications with almost a real-time validation of your input in forms, making applications feel more intelligent, more reactive, more responsive. It made it possible to support partial changes to pages. The whole Ajax revolution, Ajax is a term that's almost not used anymore, with loaders and all these dynamic elements, etc., was all based on the capabilities of JavaScript. And yeah, for this reason alone, JavaScript unlocked possibilities of web applications that would otherwise simply not have been there, and JavaScript became immensely popular. Unfortunately, though, JavaScript was not a good programming language by any stretch of the imagination. It was inconsistent, it was, not really designed, it evolved from a hobby project, and as JavaScript started to be used for larger applications, it was clear the lack of software engineering principles when building these applications was going to hurt the quality of the software built, meaning code bases that were hard to manage, an exponential growth in bugs and defects, and the more developers working together on a project, the more these issues would become evident and problematic. Slightly more than a decade ago, Microsoft decided to try to fix this by introducing TypeScript, and TypeScript was basically JavaScript plus some notions of software of programming language design derived from the principles of software engineering. So in short, by adding a type system to JavaScript, Microsoft attempted to increase the level of quality of JavaScript source codes by reducing defects, improving the ability to build modules, and to combine these modules in a way that would break less often. The results were quite successful. So TypeScript became very quickly very popular, and one thing that probably also made TypeScript very popular was that any improvement that TypeScript brought to the table was resting on two very important conceptual pillars. On one hand, one of the best of breed type systems that exist nowadays in the world of programming languages, rivaling in quality type systems of research programming languages such as Haskell, Agda, Coq, and some of the most advanced programming languages that exist in the world of universities and research institutions. So that's kind of cool on one side. On the other side, though, the syntax and semantics of the language have always been kept intuitive and pragmatic. Whereas programming languages such as Haskell, which I've used for plenty of time and I really appreciate, so don't get me wrong, do not really make any concession to pragmatism because they are really meant as research objects, and as such, well, if something is awkward, no one really cares. But in TypeScript, everything that has been done is as little awkward as possible, but never too pragmatic, because that would mean that it might be inconsistent or cause issues and defects later on. So we have one of the most pragmatic languages in the world, because it has to, take over from JavaScript and be as compatible as possible with the JavaScript world on one hand. On the other hand, we have a great theoretical foundation. So, well, let's dive into it. Our course is going to be divided into 6 lectures, you could say. We will start with the basics, where we will explore just the basic syntax of the language. We will explore things such as how to declare variables, constants, scope, conditionals, loops, and all of these basic aspects of the programming language. Then we will dive into functions, lambdas, and all of the constructs that are related to this very basic unit of abstraction in the programming language. Then we will start diving into types. We will see the types of functions, we will see the types of arrays, of tuples, but also some slightly more sophisticated types, of course, such as objects, etc. Then, within the context of types, we will look at the so-called type algebra, because given any two types in TypeScript, it is possible to transform these types by merging them together, by adding them together, multiplying them together, etc. So this algebraic property of the TypeScript type system unlocks incredible possibilities that, coupled with the so-called data flow model of the type system, gives us some pretty exciting ways of writing code that are also unique, or at least unique with respect to what we know in the most used type systems such as Java and C#. So prepared, because the types lecture is going to be long and a lot of fun and filled with aha moments. Then we will dive into generics. We will see how generic types are written, managed, and processed in TypeScript. We will not see everything about generics. There is an advanced TypeScript course for that, but we will just scratch the surface, take a look at the immutable data library. So we will see maps, lists, arrays, etc. Finally, we will look at object orientation, and interfaces, objects, classes, abstraction, visibility, properties, and so on, we will see that TypeScript is a very competent object-oriented language. And finally, for my own personal fun, and I hope for your own personal fun and interest, we will dive in a very interesting, very modern way of writing object-oriented code in practical code bases, which is called the Entity Component Framework, that allows us to build composable models of applications. All right, enough talking. Now we will dive into setting up a project. Just a word of encouragement. Well, the idea of this course is that we're going to write code together. I will write it for you. I will explain it for you. Everything will be very hands-on. Try to follow through. Try to follow the exercises that Francesco is going to record. And especially, you know, take your time. Learning programming is complex. TypeScript is an advanced language, even though it might feel deceptively simple at some point. The recordings are there to be watched and rewatched. Try to play, be encouraged to feel encouraged to play, feel encouraged to find your way through the materials, and especially give yourself the time to really absorb this beautiful, exciting, and elegant language. Okay, now I'm now going to set up the TypeScript project and the TypeScript compilation pipeline. I am in a folder, Playground. I'm in Visual Studio Code. Feel free to use whatever you want on a Linux machine. I have already installed npm, node, and yarn. npm, node, and yarn. And I'm going to use these tools and only these tools throughout the whole course. I will start by calling yarn --init. This sets up in the Playground folder, which is not full anymore, a JavaScript package or a JavaScript project, if you will. Within this JavaScript project, well, I'm going to run yarn, which simply installs. There are no dependencies, so there are no dependencies to install. We get the node modules folder set up. It's empty because there are no dependencies. Let's add a dependency with the yarn add command. The first dependency will be TypeScript. There are two sorts of dependencies. There are development dependencies, which are installed with a -D flag, and these development dependencies are only used for compiling and processing your source code, but they are not used for running the actual program. So when I add yarn TypeScript min-d, you can see that there's a TypeScript folder with the whole package of TypeScript, and in the .bin folder of the node modules there are also the executable files that TypeScript is going to use in order to turn TypeScript source files into JavaScript source files. TSC stands for TypeScript compiler, because it is a compiler. Also, we see that the package.json file has made its appearance, and TypeScript 502 is listed among the dev dependencies. I could also add a non-dev dependency. There is a package that is quite useful, the immutable package. You can see that the immutable package is now listed among the dependencies, meaning that immutable will be available to the program as it runs, whereas TypeScript will not be available for the program as it runs, but only for the program when it is being compiled and prepared for execution. Now, the files in .bin can be accessed simply through yarn. So if I say yarn tsc, I'm running the tsc executable in the .bin folder. And because TypeScript is also has its set of compilation flags, etc., I first have to initialize the TypeScript project. So yarn -init initialize the JavaScript project, and yarn tsc-init will initialize the TypeScript project. And now we have a ts-config.json file that specifies how TypeScript is going to turn TypeScript files into JavaScript files. I'm going to do two things. First, I will move to to a more recent version of the language, of the emitted JavaScript. And second, I will ask TypeScript to emit my JavaScript files that are the result of the compilation to the bin folder. You can have them wherever you want, but yeah, I mean, I like to put them in bin. You could have them in release, output, whatever. No judgment. Okay, now let me create a main.ts file, and there we go. This doesn't really do anything. Let's add console.log welcome to our wonderful introduction to TypeScript. Okay, so for now, well, this TypeScript program is by chance and by virtue of being very simple, also a valid JavaScript program. So we could run this, but this is just accidental. For even slightly more complex TypeScript programs, the source code of TypeScript is not valid JavaScript. How do we turn a TypeScript file into a JavaScript file? That's quite simple, by means of the tsc command. Now, okay, so there should be a bin folder here. There it is, with a main.js file. You can see it's basically the same. There are semicolons. Okay, they were added by the TypeScript compiler, and there's the use strict flag. Not very interesting, to be honest. Okay, now we could run this bin main.js, and there you go. You can see in the console, in the terminal, welcome to our wonderful introduction to TypeScript. Let's say I want to amend my program and add some exclamation marks. Be mindful always to edit the TS file. If you edit the JS file and you run the compiler, you will lose your changes to JavaScript. Okay. If I just run a node bin /main.js, well, the change has not really been picked up. I have to run tsc again. Instead of having to run it manually every time, a useful trick is to run tsc with a -w, which stands for watch flag. The -watch flag looks at our files and recompiles them automatically whenever one of our TS files is changed. Very handy in order to not have to recall the compiler manually every time. Look, now we have the 3 exclamation marks. Let's say that we find 3 exclamation marks a little bit too much. I'm going to now save. This has flashed. You can't really see it. And if I run main.js, well, without having to explicitly compile with tsc, the changes have been picked up. All right. I would say try to install Node.js, try to install npm, try to install Yarn, and try to follow along the steps in order to get a working TypeScript file. In the next class, we're going to jump into the basics. The next class is going to contain a lot more coding. So I hope so far you've enjoyed this first introduction. Thank you very much for following, and until next time. Bye bye!